Hello fellow problem solvers. So today we're going to be starting a different coding challenge, which is to code Connect 4 in Python. Now for those of you that don't know, Connect 4 is this game where you're dropping in, you can think of it as dropping in coins into this board. And the goal is to have 4 of your coins in the same row, column, or diagonal. So an example of a game would be like one player plays here, then another there, and the coins always drop. Like you can think of this as gravity pulling them down. Then a player plays there, bam, 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 we're playing a game. You're stopping your player from connecting 4 if you can. And then you have 4 in the same diagonal. And this is one example of winning. Another example is, say, a player played here and the game continued and we had 4 in a row. Or we could have also had 4 in a column like this. Now, for this game, the question is, how are we going to represent this board? And how are we going to represent the things that are inside the board? And for me, the thing is this board, because I can think of it as a list of lists or 2D array in Python. And so what I would do is I would like label these 0 through 5, like a 2D array of size 6 times 7. And then we will do the dropping by figuring out, okay, we're going to pick a column where we're going to be dropping. And then from there, we're going to start from the bottom and see if it's empty. And the first square that's empty, we just put the sign there. If none of the squares are empty, we should give a move that's bad. We should say this move's impossible. So now with that, I invite you to pause for like 5 to 10 minutes and like write up the board and maybe a make the move function. So now let's do that. Okay, so I am in my code editor, and now let's just like keep things general. Let's say there are 6 rows and 7 columns, and we will try to later generalize all of these things. So now first the board. How do we instantiate a board that's 6 by 7, a 2D list of lists in Python? And there's many ways to do it, but for me, what I did was I just Googled the solution, and what I found was this thing right here, a article in Geeks for Geeks. Once I just searched it, like how to make a Python 2D array, and I saw that I could make it like this, but then that doesn't do me any good, because if I change one of the elements in a row, then it changes all of the elements in all the other rows. So I used this other method, and the thing I did was just, let's copy this, and then let's paste it. Great, so now we're going to paste this. So instead of R, I'll just call this my board. And now we have our board, and now we can change stuff. So because we're going to be calling this make a move thing a lot, the best thing to do is to call it, make it a function. I mean, there's other ways I guess you could do this. You could make this whole thing into a big function, but I'm going for these things to be more easily debugged. So when we make mistakes, I want to be able to fix those mistakes more easily. So the move is going to be, let's assume just that the move is less than the number of columns. And the number of columns, how do we get that? Well, if I click the length of board will give me the number of rows. The length of board of 0 will give me the number of columns. So I'll just go through. Now I need to go through the rows, so I need to know how many rows there are. So rows number is going to be the length of the board. And now I'm going to start from the end and going to try to find the next, the next free square for me. So how do I do this? Well, the next square is going to be x is board of. So we're going to have rows number minus I minus 1, if I'm not mistaken, because we're starting from 5 and this starts from 0. This starts from 0, so we're going to start from 5 here, and that's going to be 5 minus, this is going to be 6 minus 0 minus 1 is going to be 5, and then the column is the move number. So now we check if x, so if x isn't 0, so if x is not equal to 0, then we make a move here. Then we say board of rows number minus I minus 1, and the move is going to be equal to, let's just say 1 at this point, because I think we will need a sign here. And if it's not, then we just continue on. And if it is, after doing this, we need to break out of the loop and return the new board. So now let's just call this once. Let's print the board once, and then let's make a move. Actually, let's not just make a move. We're going to have board is equal to make a move on the board, and which move? Say move number 3. And then I'm going to print the board again. And let's see what happens here. And nothing has changed. So if x is equal to 0, I want to change things. So now there's a change. There's a change happening. This was move 3. This is the first. This is the first row. So let's just also make a function that just prints the board nicely. And that's just going to go through all the rows in the board and just print the rows. So now instead of just printing the board, let's do a print nice. There might be a built-in function that does this, I don't know, but it doesn't take too much to just make this yourself. And let's just make things easier. Let's play a hub. And what do we have? Yes, we have it. So the make move function works. Now we need to create the thing that's going to allow the players to play one after the other. Now we should also add a sign here, the player's sign. That's happening. So a sign, and if we're not able to make this, I feel like if we weren't able, we can check this out later. What happens if we can't actually make the move? So now let's think of, and let's make the sign here, 1. So we're going to have 2 players. Let's say player 1, and let's call this their sign. See, their sign is 1, and player 2 is going to have a sign that's 2. So now we need a while loop. Let's get this out of the way. So we print the board, and now while game is on, we are going to be getting moves. So let's do this. So while game is on, we need to get the moves. And I invite you to pause here for 5 minutes and figure out how are you going to be switching the moves of the players and printing it out at the end. So now I hope that you pause and think is okay, we first need the input. So the move is going to be an integer of the input, and we're going to say, give me a move. Then you're going to have a move. So after we've done that, we need to make the move, and we need to know also who is playing. So let's say current player is equal to 1, the first player. So then we just we make the board equal to the make move on the board, what we need, the move, and we need the current player. Beautiful. And now that we've done this, let's print the board nicely. And after we printed the board nicely, let's also change who the player is. And now that we're just doing player 1 and 2, signs 1 and 2, I would just write current player is equal to, so because 1 needs to go to 2 and 2 needs to go to 1, I'm thinking of a function that's very simple here, which is I can write this as a linear function because I have 2 variables, A and B. I have 2 inputs that are mapped to an output, and this gives me that the current player is going to be equal to 3 minus the current player. So now with that, we have the current player, but we'll update this as we go along. And now let's see what happens. And maybe let's just have if I input, say, if move is equal to -1, let me just break out of this loop, just so I have a way to end it without causing any havoc here. And then we'll print bye. So let's see what happens. Let's see, we've done what we needed to do. Give me a move, I give you a move 3, 2, and now the players are playing. They can input stuff. Nice. Actually, 7's too much. 6, 1, 0. Oh, okay. And if I input a move that's too big, this whole thing will break. Nice, nice. But the whole thing works at this point. And now with this, we need to implement, well, a couple of things. Well, we can check that this move actually is, well, there's a lot of things we can check. We can make sure that it's an integer. Say if I'm inputting like a num as, then this is not going to be a valid literal. So we can do a lot of checking, but for now, let's just assume the moves are good, they're integers, and let's just check that the move is going to be, let's see how to actually do this. So if move is going to be, is greater than, actually we can just do this. If move is less than or equal to how many rows we have, no, how many columns we have. If it's less than or equal to number of columns, and it's greater than or equal to, and it's just great, let's say greater than -2, then we can just do this thing right here. Otherwise, if I put in an 8, it'll just say, give me a move again. Oh, 7. Oh, yes, it needs to be, yes, less than the number of columns. And so now if I put in a 7, it'll say, yeah, give me a move. Give me a move. I put a -34. No, it's not accepting anything, but I put a 3, and we're good to go. So now with this thing saved up, let's take some time and try to figure out how we are going to now calculate if somebody has won or not. And I invite you here to pause for another, 5 to 10 minutes and figure out the winning condition. So while game is on. So after this whole thing is done, if somebody gave a valid move, we need to do something that checks if there's a win. Check win of the board. And maybe you want to make this even more concrete. So let's write this function, check win of the board. Here, I'll invite you actually, before I go away, my next sort of idea is I invite you here to pause for about 5 to 10 minutes and think, what would you do next here? And for me here, the thing is that when somebody places a thing here, so say when somebody placed a heart, somebody, not one player places their X here, and then I don't need to check what's happening around here. I just need to check if there's a win here, a win here, a win somewhere here. And likewise, when somebody places a heart here, I just need to check the rows, the diagonals, and I need to check the column. And in this case, the column gives us a win. And now with that in mind, we have a different, and this will be different depending on what sort of thing we're checking. Say here, we're going to need to check every diagonal. And we might sometimes need to check, you can imagine a situation where the heart was already there and a player placed a heart here, and then you need to check both forwards and backwards in the diagonal. And that's going to have some complications, but that is what we need to do. So now if we just do the naming, now what does that mean for us? So it means if we have some I and j, if somebody places something here, so how are we going to, we need to check the rows, the columns, and the diagonals separately. Like there's the 4 diagonals, not the 4, the 2 diagonals, the column and the row, and the column and the row. So how are we going to do this? Well, let's call all of these separate functions, and now let's go back to our code base and actually do that. Now, given that, I'll also not just like look at the board, but also put in the move here when I'm checking the win, the move that was played. And then I can sort of figure out, okay, because I know which move was played, I know where it is on the board. So first let's locate the X and Y, the I and J coordinates here. And how are we going to do this? Well, we need to start from the bottom of the rows. We need to have, so the number of rows, and then we need to start from the bottom and work our way up to the top to sort of figure out where we've played the move. So like first figure out where the move was, and it's going to be the final thing in this range. So we start from, so current is going to be equal to the, what are we looking for? We're looking for boards of number of rows minus I and the move. And what do we care about? We care if the current is equal to 0, then we know that the move was made on a previous, actually minus I minus 1, as we've done separately, minus I minus 1. So if the current was 0, then we know that the thing was done in a separate thing, and I think we still have that I saved. So that will mean that, actually let's check what happens here. Print I and print board. Just so we check what happens. So this will be called, I'm going to place a 4, and it says 1. So I is 1. That means after I've played the move, it came here. Let's actually play a bunch of other moves. Okay, now I is 2 once I've played it here, which means what does this actually mean for me? So I starts from 0 and I got to a 1. Oh, yes. So the previous one, so I minus 1 is the location of our thing. So let's just get out of this. So if I place a 4, so yes, the 0 is the location of, actually no, not 0, it's 5 minus 0. So I'm looking at board of num rows minus I. Is it minus 1? I'm curious now. Move. Let's see if we've done this right or not. Get out and call it move 4, 0. So we've not done this right. And the problem is, so what is this? It's going to be 5. So this is going to be 6 minus 1. So 6 minus 1. I think it's just in 6 minus 1 because I is going to be at least 4. I'll give you a move 4. And yes, it's a 1. Beautiful. So we've located this. And now with this, we know that this is where we have our move. So we've placed our square, we've placed the thing in row placement. Row placement is number of rows minus I, and the move and the column placement is equal to the move. Now we need to check a win around, check win in the columns of the board and around this like column and row placement. We could have done all of this separately in here, but it does make sense because we'll just copy work. Then we need to check win for the row on the board, in the column P, and the row P. And we need to check win on the diagonals, on the board, the column P, and the row P. Doesn't make sense. It makes sense to put the columns, it doesn't matter actually, because we'll just be using this thing to check if we won. And now here, I actually invite you to, and this seems to be a good place for us to pause, and we can see that we'll continue next time with this Connect 4 challenge. This is just the beginning, and I'll see you in the next video. And as always, thanks for problem solving.